Hello and welcome to our fourth video on probability. I'm Mr. Chowdhury and today we're going to be looking at theoretical and experimental probability. So if you haven't already, I suggest you go watch our first three videos because without those you will find it difficult to understand some of the key concepts in this video. So you need to know what a probability is and how to find the probability of single events before you can do anything here. So our first task, or our first thing we're going to be looking at, is we're going to be looking at probabilities of dice. So that's what we're going to be looking at, probabilities on a single die. So the first thing we're going to ask is, what's the probability of rolling a 4 on a die? So if I take a die, what's the probability of me rolling a 4? I'd like you to pause the video, have a think, and we'll come back in a second. Okay, so on a dice, there are 6 possible outcomes and only one of them is a 4. So the probability of rolling a 4 on a die is 1/6. So here's what we're going to do. So you're going to come along with me to my whiteboard. And here's what we're going to be doing. We're going to be rolling a single die. We're going to be rolling a single die 30 times. And we're going to take a tally of that experiment. So we're going to do a little bit of experiment. We're going to roll a single die 30 times. What I'd like you to do is pause your video, see if you can get a hold of a dice. If you can't, you can just watch my animation and go from there. But if you can, I'd like you to have a go at it yourself. So roll a single die 30 times and keep a tally of what you get. What I'm going to do now is pause the video, allow you to go and get the die, and then I'm going to do a speed run of me rolling this die 30 times. So pause the video, go get a dice, and then watch me roll a die 30 times. Okay, so there, I've rolled that dice 30 times, and this is what I've come up with in my tally chart. So my tally chart shows the following, and those values are: I rolled 6 1s, 5 2s, 7 3s, 7 4s, 1 5, and 4 6s. And we can see that if I was going to work out my probability of getting a 4, my 4 would be 7 out of 30, and that's not equal to a sixth. And you might be thinking to yourself, well, why is that? And that's because there is a difference between our experimental probability, which is what we've just done here, and our theoretical probability. And I'll show you something that will make a bit more sense now. So if we look at this little experiment that we've got here, the one that we've just done in practice, if we were to do more trials, if I was going to roll this dice more times, if I just roll this dice as many times as you can, as many times as I can, as you will notice, the more I roll it, as I keep rolling this dice and I keep going up and the values go up. If we look at that graph in the top corner, so this one here, we can see that as the number of rolls increases, those values of rolling a 1, 2, 3 and a 4 get closer together. They're becoming more and more equal. And as I keep increasing my rolls, they'll get closer and closer and closer until they become the experimental probability. So as I keep going, we can see, if I pause it here, if I just stop after 508 rolls, they're not very far off. We're very close. Compare that to my version that I did earlier, and it's very far away. And if I just keep going, they'll get even closer and even closer and even closer. So if I was to roll the dice 1,000,000 times, the chances are that if we looked at our diagram, we would end up with a sixth of each number. And the more times I choose to roll that dice, the closer I'm going to get to that theoretical probability. And that's because of one key fact that you need to understand moving forward, that the theoretical probability is what we might get, the experimental probability is what we do get. But the key thing that you need to know is as follows: that the larger the number of trials, the closer we can get to the theoretical probability. The more trials we do, the more reliable we can be. Think about it in terms of flipping a coin. If we flip a coin 10 times, chances are we're not going to get 5 heads and 5 tails. That's not going to happen. However, if If we flip that coin 1,000 times, we're going to get closer to that 50-50 split. If we flip it 1,000,000 times, we're going to get even closer to that 50-50 split. The more trials we do, the closer the experimental probability gets to the theoretical probability. So I've said a lot of definitions here, so I'm just going to give you those so you can copy them down or screen grab them. So the two key things to remember is the definitions for theoretical probability and experimental probability. So the definition for a theoretical probability is the chance of an event happening in theory, what we expect to happen based on what we see within the situation. So for example, flipping a coin, rolling a dice, what we expect to happen. So if you flip a coin, we know there's only two options, and we know that tails is one of those two options, so the theoretical probability is a half, and so on. The experimental probability is not actually a probability in itself. It's more a representation of what happens in practice, what we see when we carry out an event in real life. So for example, when I just rolled those dice, the experimental probabilities are what actually happened. We could see the representation of what happened when I rolled that dice 30 times. And we've said the more trials we do, the more times I roll that dice, the closer I will get that experimental probability to the theoretical probability. So before we move on and we do anything else, what I'd like you to do is pause the video and have a go at answering these questions. And then I'll go through the answers with you in a second. So just pause the video, have a go at answering these questions, and I'll go through the answers in a second. Okay, so let's go through these answers now. Let's go through these answers. And to do that, we're just going to go to our whiteboard so you can see what the answers are. So the first question was, what's the probability of getting a 1? Well, on our spinner, we can see that there are 2 1s out of 6 possible options. So that's 2/6 or a third. We don't need to simplify it, but if you did, it's not the end of the world, and that's either answer is correct. So for question 2, the probability of getting an odd number, well, I've got 2 1s, a 3 and a 5. So that means I have 4 odd numbers out of 6 possible options, or that's the same as 2/3. They're both the same, they give you the same answer. Now, the last question is the spinner fair? Explain your answer. Well, if we look, there are 2 1s on that spinner. So that means that spinner is not a fair spinner. It is a biased spinner. You are more likely to land on a 1 than you are on the other numbers. Therefore, that spinner is not fair. Okay? Now let's look at the experimental probability questions. So we said Barry spins a spinner 300 times. How many 1s does he expect? Well, the maths I'd need to do is the following. So if I've got 300 spins, and I know out of those 300 spins, 2/6 of them are going to be 1. Because I've said of 2/6 of them, I know I'm going to multiply those together, which will give me 100. So I expect to see 100 1s when Barry spins that spinner 300 times. I would expect to see 100 1s. Whether that happens or not, Barry would have to spin the spinners to see. But for all intents and purposes, that is what I would expect to see. Now, the next question, Gwyneth says that if you spin the spinner 6 times, you will always get a 5 once. Well, that could happen, but that's probably not going to happen, but there's a chance of it happening, but it will definitely not always happen, right? Because the number of trials is very low. 6 times is not a big number of trials, so she's not correct in this statement. Her statement is incorrect. It could happen, but it probably won't happen. And the last question we're going to answer together is completing this sentence. So it said it should be the more trials we complete, the closer the experimental probability will be to the theoretical probability. And that is what you need to know about theoretical and experimental probability. Now, hopefully that's been helpful. What I suggest you do is you go and watch Mr. Amison's video to do some practice. If you're feeling super confident and you think, yeah, I can do this, I understand, go to Dr. Frost and Corbett Maths to practice some questions on there on your own. You go off and be productive, and I will see you in the next video.